Okay, so for this video we will talk about empirical formula and molecular formula. Okay, what does it mean by empirical formula? Empirical formula is a formula that showing the simplest ratio of element in a compound. Okay, so what does it mean? We will see the example later. While molecular formula is showing actual number of element in a compound. Okay, this one the keyword is simplest ratio. This one the keyword is actual number of element. Here I giving you C6H12O6, which is your glucose, and from this structure you know that you have 6 carbon, 12 hydrogen and 6 oxygen. And from this structure you call them as molecular formula, because you know in the structure you have 6 carbon, 12 hydrogen and 6 oxygen. Okay, from this structure you know that you can simplify them become CH2O. How I get it? You will divide by 6. Okay, 6 divided by 6 you get 1, and 12 divided by 6 you get 2. So it becomes CH2O. So that is the difference between molecular formula and empirical formula. Simplest ratio, actual number. Okay, so what is important for you to know about this formula? From the experiment, we can determine our empirical formula. Okay, so there is a method for you to determine your empirical formula. So that's why you need to know what is your empirical formula. Remember, your empirical formula is your simplest ratio of element. Okay, so here is the example of questions taken from IGCSE paper. Sulfur dioxide react with aqueous sodium sulfide to produce a compound with following composition. Okay, you have 29.1% sodium, 40.5% sulfur and 30.4% oxygen. Okay, so if you add all the percent, the total will be 100%. You try to use to add all, you will get 100% total composition. Okay, so from this information you can find your empirical formula. That's why they ask calculate empirical formula. Okay, how to calculate your empirical formula? You should draw a table. Okay, this table you should have 4 rows. 1, 2, 3 and 4. Okay, if possible you make it bigger row. Okay, so the first row, the title will be element. Okay, so next row it will be mass. Next is mole, and the last one will be ratio, or you call them as simplest ratio. Okay, simplest ratio. Okay, so now after you make a 4 row, you count how many elements you have. From the question you have element sodium, element sulfur and element oxygen. Means you have 3 different elements: sodium, sulfur and oxygen. Okay, so now I will add 3 more column. 1, okay, you need to add this row, and 2 column 3. Why 3? Because you have 3 different elements. And as you know, the title here is element, so the first element that you have is Na. Okay, here is stated as Na. Next element you have sulfur, so you put sulfur. Next element you have oxygen, so you put O. Okay, so now you know to know the mass. Okay, here you doesn't have any information about mass. It's give you about percentage. So you can use the percentage as the real mass. Now for sodium, it stated that 29.1% of sodium. So it's actually 29.1 mass for sodium. Okay, you can take the percentage as the mass value. Okay, so for sulfur the mass will be 40.5. Okay, for oxygen it will be 30.4. Okay, so now you know all the mass of each element already. Now you need to find your mole. Okay, so mole, as you know that you have 4 formula of mole. So which formula you should use? Look at the informations that you have. The informations that you have here is your mass. Okay, mass. So means the mole here, you should use the formula of mole equals to mass over molar mass. Okay, why? Because you have the information about mass. So here my mass is 29.1. Okay, divide by molar mass. Which molar mass? Sodium. Okay, so if you found that the sodium is at the mass is actually 23. Okay, you get 23. Okay, next is for sulfur. Mole for sulfur will be mass. Okay, using the same formula because we have information about mass. It will be 40.5 divided by molar mass for sulfur. Please refer your periodic table. And the molar mass for sulfur is stated in periodic table as 32. Okay. And next, find the mole for oxygen using the same formula. 30.4 divided by 16 from your periodic table. Okay, now we need to find the mole. I need to get my calculator. Okay, so here you have 29.1 divided by 23. You get the the mole equals to 1.27. Okay, and then you find for sulfur 40.5 divided by 32. It will be 1.27 also. And you find for oxygen 30.4 divided by 16. You will get 1.9. Okay, so here the rule for the simplest ratio, the rule say that divide by, okay, so I made note here, divide by smallest mole. Okay, so if you see here, you have 1.27, 1.27, 1.9. So the simplest mole here is 1.27. I mean the smallest mole, 1.27. So for this simplest ratio, the mole here, 1.27, must be divided by smallest mole, which is your smallest mole will be 1.27. So you get 1. Okay, so this one, the mole is 1.27, and the rule say that divide by smallest mole. The smallest mole that you get is 1.27, right? Okay, this one is bigger, so of course this is the smallest mole lah. 1.27, so you get 1 also. Okay, for oxygen, the mass you get is the mole you get is 1.9, but you must divide by smallest ratio. The smallest mole. The smallest mole that you get is 1.27. So this one must be divided by 1.27. So you will get 1.9 divided by 1.27. It will be 1.496. So I take as 1.5. Okay, so simplest ratio, you cannot get decimal number. Here you get decimal number, which is 1.5. Remember, you cannot round this to become 2. It's not simple as that for you to round off. Okay, if you get 1.01, yes, you can make it as 1. Okay, if you get 1.9, you can make it become 2. But if you get 1.7, 1.8, 1.6, 1.5, you cannot change this become 2. Okay, it's not simple as that. If you get 1.1, 1.2, 1.3, 1.4, you cannot change also them become 1. Okay, so here you have a decimal number. So you need to think how you can change this decimal number to make it as a whole number. Okay, so you can multiply this by 2. Okay, if you put 1.5 times 2, you will get 3. Okay, why? Remember, you cannot have decimal. You must have whole number, integer. Okay, so to change 1.5 become integer, you must multiply by 2. But in mathematics rules say that if this one is multiplied by 2, all of this also must multiply by 2. So 1 times 2 you get 2. Sodium also you get 2. Okay, so now the number is more nice, 2 to 3. Okay, so your new ratio will be 2 to 3. So your empirical formula will be Na2 Y2 big 2 from here. Okay, so S will be 2 from here, while oxygen you will write down 3. Okay, so you see the number, it's simplest already. You cannot simplify the number again. So the empirical formula for this question is Na2S2O3. Okay, so this is the technique for you to find your empirical formula. For you to have more exercise, please refer to the questions that I give to you. There is some question is asking about your empirical formula, so you can try to answer that question using this technique. Okay.